So, how would you distinguish between the first, second, and third ionization of an atom? So the first ionization, and in this case I'm just going to use an example of, say, oxygen. So oxygen's electron configuration is 1s2, 2s2, 2p. I really need to get better at just writing the things I'm saying. 2p, 4. Okay. So oxygen's first ionization energy would be removal of one of these 2p electrons. So it would be going from O to O plus. And so the configuration would be going from 1s, move it, would be going from 1s2, 2s2, 2p4, to 1s2, 2s2, 2p3. All right, so we're removing one of the outermost electrons and ionizing the atom, because now there's only 7 electrons and 8 protons, so now we have a positively charged species. Okay, so the first ionization energy removes the an outermost electron, or the outermost electron, giving you a positively charged species. And this was the 6th question. Okay, so the second ionization energy then goes from there. So we're going to remove another outermost electron from our ionized species from the first step. So again, continuing with our example with oxygen, that would be going from O plus to O2 plus, and going from an electron configuration of 1s2, 2s2, 2p2. So now in this case, we're removing an electron from a positively charged species. Recall that the potential energy, or the energy for electrostatics at least, is 1 over 4 pi epsilon naught Q1 Q2 over R. And we're trying to take our electron, which would be Q2 in this case, or what I'm calling Q2, away from the proton. So this is our O, in this case O plus species, or actually our O2 plus species, as it's everything except that electron. So we're trying to remove the electron from that species. So it's a 2 positive core, especially as we start to remove it, it's going to be even harder to remove than in the first case, where in this case it would be just a single positive core. Okay, so we've got a higher positive charge we're trying to pull an electron away from, so it's going to be even harder. And then the third ionization is then just removing another electron, which, continuing in our example with oxygen, is moving from 2 plus to 3 plus, or from a configuration of this to this. And as in the previous, removing an electron from a 2 positive to make it a 3 positive is going to be even harder than the second and the first. So that means that the energy always increases from first, second to third. Okay, so it always takes more energy for the third ionization energy than the second and the first, and it's just because you're now removing electrons from a positively charged core. Okay, so now looking at what the solution is, or what the solution is given as. The first ionization is the amount of energy to remove the outermost electron from a neutral. The second is the energy required to remove another, which is always higher than the first. And the third is the energy required to remove it from the 2+ to make a 3+, and it's always larger than the second and the first, obviously. Okay, so that looks good.